Good morning, students. Myself, Dr. T. Sudarshan Rama Parmar, Associate Professor, Department of Electronics and Communication Engineering. Today, we're going to see about some of the IoT protocols available for communication. First, we go for the IoT protocols. Data flowing from or to things is consumed and controlled or monitored by data and center servers, either in the cloud or in locations that may be distributed or centralized. Dedicated applications are then run over virtualized traditional operating system or a network edge platform. These lightweight applications communications with the data center servers. Therefore, the systems communications combining various physical and data link layers call for an architectural approach with their common layers independent from the lower or upper layers. This is the IoT protocols used for their communication. In the data link layers, we have the 802.3 Internet, 802.16 WiMAX, 2G, 3G cellular communication protocols, then 802.11 Wi-Fi, 802.15.4 low range of wireless personal area networks, and the network layer we use the IP version 4, IP version 6, and 6 low power wireless personal area networks, and transport layer we use the transmission control protocol, user datagram protocols, and application layer we use some of the protocols HTTP, MQTT, CUO, FTTS. IoT works on various networking technologies based on the IT infrastructure requirements, and therefore it needs architecture to establish a concurrent IoT ecosystem. Here IoT protocol layer contains the network layer, application layer, perceptions layer, security layer, and the edge layer. Considering the complexity involved in the configuration, operation, functionalities, and communication, the 5 layers of IoT architecture are best suited for all purpose. Network layer, its core functions is to connect the IoT devices with the network system and servers. The network layer also helps to route and control the data transmission with the help of a set of communication protocols and identified formats. Utilize the transmission control protocol, IP stacks, and cellular and wireless technologies. Depending on these specifications, the network layer helps set up secure transmission across all interconnected devices. We have few examples of IP version 4, IP version 6, and some examples are IP version 4, IP version 6, ICMP, ARP, UDP, 6, LOPN, and Wi-Fi. Application layers. It acts as an interface between the IoT devices and the end users or any other devices that requires the information over the secure network. After successful data processing, formatting, and presentations, it produces a final information. A few examples of an application layer are HTTP, FTP, POP, IMAP. The IoT application protocol depends on 4 critical parameters: representation of state transfer, constrained application protocol, advanced message queue protocol, message queue, telemetry transport, and establishment message and presence protocol. Perception layers. It constitutes sensors, actuators, and AI-powered devices to gather valuable detail about the surrounding physical objects or the environment. The accumulated data is converted from analog signal to digital format for further operation. Its functioning include identifications, information collections, and automated control technologies to channel the digital and real world. A few examples of the perception layer include surveillance camera, barcodes, portable PCs, RFID, wireless sensor network, and GPS. Security layer. It minimizes the risk of proportional cipher attacks on the most vulnerable areas of the IoT ecosystem. The security checkpoints occur at 3 significant places: the devices, cloud, and connections. With the rapid digital evolution during the outbreak, the security challenges and underlying threats to the IoT architecture also grew exponentially. Therefore, the layered secured approach has become the utmost important in the ongoing scenarios. A few examples of the security layer include trusted platform modules, which is multiple of authorization firewalls like that. It works on the edge layers. It works on the edge computing framework to improve latency, bandwidth, and real-time communication challenges. The edge layer privacy goal is to fetch and process the required information closer to the data sources. With the ever increasing number of the smart devices over the centralized cloud systems, and the delay in response is a significant concern. However, combined with the 5G and AI capabilities, Edge IoT layers perform exceptionally well for the giant sensitive data and delivered faster results. A few examples of edge layer include the electronic vehicles, smartphones, smartwatches, laptops, security cameras, public transit layers, smart cities, green technology. A 5 layers of IoT architecture facilitates the smooth functioning of an IoT ecosystem. Besides, they can accommodate expansions and handle entry case of the following latest technologies advanced. The goal is to establish seamless IoT interoperability, taking care of the challenges, capabilities, and cybersecurity. Functionality is based on IoT protocol organization, connectivity, identification, communication, discovery, data protocols, device management, semantic, and multiple layer frameworks. So these are some of the exam introduction about IoT protocols.